chapter 3 of It's the Thought That Counts by Dr. David Hamilton. This is DNA. DNA is frequently in the news at the moment amid reports of cloning and the genetic modification of foods. Cloning is where scientists copy the genetic code found in DNA and produce a genetically identical animal or plant. Dolly the sheep was born from a cloned genetic code. Modifying the code would produce something that was similar yet different, a normal-looking grain that was resistant to infection, for instance. This is typical of some of the research that has been done on GM foods. But while all of this research has been going on, a new area of DNA research called Psychosocial Genomics has emerged, a blend of psychology and genomics. Its essence is that your DNA is influenced by how you think and feel. But before we go into that, here is a little lesson on DNA. DNA is short for deoxyribonucleic acid, something like that. So you may understand why people prefer to call it DNA. Scientists have known for years that it has a double helix structure from the work of Crick, Watson and Wilkins, who received the Nobel Prize, and Rosalind Franklin, which was published back in 1953. Can you picture a spring in your mind, say a bed spring or a child's slinky spring? But instead of it being made up of a single line of wire, imagine that a railway line had been coiled into a spring, so there are two lines. Imagine that just like a railway, there are slats connecting the two strands. The two strands connected by the slats form a double helix. That's what DNA looks like. The Human Genome Project that you may have heard about was an international research program set up to crack the genetic code. Scientists wanted to know the exact chemical makeup of DNA. You would have heard of genes. Each gene is a small section of DNA whose presence causes you to have a particular physical characteristic, like eye colour or hair colour, for instance. Imagine them as light bulbs, a coil of several thousand of them making up your DNA. In the Human Genome Project, scientists wanted to know the exact sequence of light bulbs, as in which bulb came first, second, third. Bet you didn't know that approximately 99.9% of genes are the same for every person on Earth. In other words, you and I have almost identical genes. Most people are under the impression that our genes are very different, and having, say, brown hair means that a person must have the brown hair gene, and having green eyes means they have the green eye gene. This makes logical sense, but it's not entirely correct. Many of the differences between people at birth actually have little to do with whether they have a specific gene or not, given that we all have almost the same genes. The differences are mostly due to tiny variations in single genes. Using the light bulb analogy, a single bulb would represent each gene, but if you were to look inside each bulb, you would see that its element was made up of a further 1,000 similar bulbs. Scientists believe that the main difference between individuals are in the colour of just one of these 1,000 smaller bulbs inside a single gene. These variations are called single nucleotide polymorphisms, and about 3 million are believed to exist. However, this is only part of the story, because after birth, differences begin to emerge due to specific genes switching on in some people and off in others. Imagine a row of 10 light bulbs. I may have bulbs 2, 4, 6 and 7 switched on and the rest off, while you may have bulbs 4 and 6 switched off, but bulb 8 switched on. In the human genome, it is a little more complicated, with around 25,000 genes, but the light bulb analogy is a good one. There are a number of factors which causes genes to switch on and off, including the normal workings of the body, diet, and exercise. But throughout life, our numerous experiences, and more importantly, how we think and feel about these experiences, also cause genes to switch on and off. Say you have a meeting with someone. How you feel about them and what you think about them afterwards will determine whether certain genes switch on or off. So our thoughts and feelings produce significant biological differences between us. Learning has been proven to do this too. Differences in what each person learns leads to differences in which genes are switched on and which are off, which in turn lead to differences in the growth of the brain and the differences in the body due to the body-mind connection. The activation of genes is also a significant reason for the differences between us and other species of life, although we are hardly likely to mutate into another species. For example, there is a 98.5% similarity between our genes and those of chimpanzees. Similarly, 50% of our genes are shared with a cabbage, 51% with yeast, 50% with a worm, and 30% with a banana. Unbelievable, but true. The differences are mostly down to which genes are naturally on and which are off, and how long they are on or off for. Our bodies are mostly composed of proteins, which are constructed when genes switch on. They are the building blocks of our body, just as bricks are the building blocks of a house. So between species, most of the same proteins are present, but they are produced at different times and in different amounts. Therefore, just as the same set of bricks could be used to build a variety of different shapes and sizes of buildings, the same set of genes can produce an infinite variety of species. Subheading: influencing our genes. The effect of our thoughts and feelings on our genes raises the question of how far we can influence our genes. It seems that the effect varies between genes. In some cases, genetics, nature, might contribute around 50% of a person's makeup, both physical and psychological, although their number varies depending upon a person's age and the physical, physiological, or behavioural traits in question. The remaining 50% would be open to the influence of the environment, brackets nurture, which includes diet and lifestyle as well as thoughts and feelings. However, it is very difficult to attach percentages to this because there is a constant interplay between nature and nurture. So genetic plays a significant role, but so does life experience. Both nature and nurture are important. For instance, if two people inherited almost identical genes, identical twins for instance, but lived in different environments and were exposed to different diets and life experiences, they will probably grow up to be different heights. Scientific studies involving identical twins have in fact shown that height is around 80% heritable, a measure of the relative genetic influence, and the remaining 20% is open to the environment. So while two people may have inherited the same predisposition to be tall, their diets and daily experiences will be the deciding factor as to what height they actually end up. Almost any particular attribute or state of health could be changed, perhaps with the aid of willpower and faith. I believe the question is not whether a thing is possible or not, but how much willpower and faith are required. Genes and visualization. In a 1998 scientific paper, Professor Eric Kendall, year 2000 Nobel Prize winner in medicine, pointed out that all bodily functions are susceptible to how we interact with life. His research focused upon how memories are stored in the brain. When you experience something, say meeting a new person or even something as simple as enjoying a meal, it is stored in the brain as a memory, forming neural connections, or depending upon the intensity of the experience, forming brain cells in a process known as neurogenesis. Intense experiences, like those of artistic or spiritual nature, or ones accompanied by a high emotional charge like excitement, fascination, wonder, awe, or enthusiasm, produce neurons, whereas normal everyday experience produce simple neural connections. You could picture it as intense experiencing producing balls and normal experiencing producing thin fibers. But in each case, it is not so much as the experience itself, but our thoughts and feelings about the experience that cause this. So when something significant happens, our thoughts and feelings about it switch on genes that construct whatever proteins or cellular components are required for its storage as a memory in the brain, biologically encoding it, so to speak. This is David Hamilton speaking. I personally believe that memories are not just stored in the brain, but that they have an equivalent all throughout the body, since the entire body is hardwired to feel every emotion. It's just that science hasn't looked anywhere else yet. close brackets. Any experience that is mentally and emotionally significant forms a strong lasting memory because it is played over and over in the mind. As it is replayed, the genes repeatedly express their information, building up an indelibly etched memory or biological equivalent, which can be a neuron if the experience is significant enough. Think of a time when you had a powerful experience, a first date, for instance. Did you think about it for hours afterwards, even days? Did you daydream about it, even make up extra stuff in your mind? Of course you did. It is this creative replaying or daydreaming that causes the repetitive gene expression, the switching on of the light bulb over and over again, that eventually produces neurons and neural connections. And if you think about it, replaying or daydreaming is visualization. So in other words, visualization, including the feelings associated with the images, inspires genes to switch on, causing the growth of proteins and cells. The more you visualize and the stronger the emotional charge accompanying the images, the brighter the light bulb becomes and the more proteins and cells you construct. You might now understand why it was possible for the man mentioned earlier to completely regenerate his liver. His repeated visualization undoubtedly switched on specific genes that cause the construction of healthy liver cells. In fact, our intentional and unintentional visualization inspires DNA 24 hours a day, 365 days a year. We are simply unaware of the process, so we continually affect our genetic code, and the nature of the effect is largely down to the nature of our thoughts, feelings, attitude, beliefs, and intentions. Put this into perspective in relation to health. So this is it. When we are ill, we tend to dwell on the illness, which is normal because illness is usually unpleasant and difficult to forget. But in thinking about it, it is likely we're actually helping to build new cells with the memory of disease. And mental images and their associated feelings of gloom will switch on specific genes that build up disease cells in our body. On the other hand, if we release our emotional pain through talking with someone or having some sort of therapy, then begin to dwell on positive, appreciative thoughts and feelings, we will encourage the growth of healthy cells. This is why hypnosis has been shown to be a powerful tool in the healing arts, and is possible also why releasing suppressed negative emotion can send cancer into regression. In fact, it has been theorized that spontaneous remission from cancer, where it vanishes virtually overnight, is a switching on of the interleukin-2 gene as a result, of tremendous faith, hope, determination, visualization, a complete change of belief system, or some other powerful experience. When turned on, this gene turbocharges the immune system, causes a neutralization of cancer cells and other harmful pathogens. So even if a person has inherited a tendency from oncogene gene, a cancer gene, to be switched on, a significant change of mind could switch it off. If a person inherited a SNP, which is a small, tiny variation in a gene that produces a disease, David Hamilton says he believes that it is possible that with willpower and faith, they can create a new program to switch genes on and off and cancel it out. This is not to say it would be easy to do so, it simply means it's possible. Our current understanding of this process is primitive, but it does suggest that such things are possible and that there is probably a way to perform such miracles at will. Some individuals may unconsciously do it all the time. Perhaps that will be more commonplace at some point in the future. Genes and love. One of the most powerful effects of heart and mind on DNA that has been reported to date is in the scientific journals is the effect of love or lack of it. In 2003 and 2005, scientists showed that gently brushing rat pups for 15 minutes a day during their first week of life altered the activation of specific genes so that the pups grew up to have a better memory, improved mental abilities, and a better ability to deal with stress. In 2006, scientists from the Department of Anatomy and Neurobiology at the University of California at Irvine found that daily handling reduces stress hormones in the brain. Handling only once did not have a lasting effect. Regular handling turned the light bulbs, brackets genes, that produce certain stress hormones down a little, and this led to a better long-term ability to deal with stress. In 1995, while also studying rat pups, researchers had showed that when a mother's touch was deprived, there was a dramatic reduction in the level of important growth hormones in the infant's body. Growth hormones are the substances that cause cells, organs, and individual body parts to grow, so they have prime importance in the bodies of children. The researchers studied two genes called C-MYC and C-MAX, which switch on a gene called orthonine decarboxylase, ODC, that is involved in the construction of growth hormones in the body. Maternal touch promotes the activation of C-MYC and C-MAX, leading to a normal growth of an infant. I think just knowing that it does it, it's nice to have the science to back it up, but we don't have to memorize all that. However, the researchers discovered that if maternal touch was deprived for 10 or 15 minutes, there was a significant drop in ODC gene expression, which went down to 40% within 2 hours. 40%, that's a massive drop in growth hormone levels. In other words, deprivation of touch has a stunting effect on growth. This might give you an idea of the importance of love. A mother's touch makes an infant feel loved, and the love promotes its growth. When there is no loving touch, the infant experiences feelings of fear, the absence of love, and this suppresses its growth. Love promotes growth, and fear suppresses it. A number of social workers investigating neglected children have actually reported coming across abnormally small children who were later found to have extremely low levels of growth hormones and to have difficulty fitting in. The feelings experienced by the children presumably switched off C-MYC and C-MAX, thereby slowing the growth process. The condition is known as Psychosocial Dwarfism, or non-organic failure to thrive. Please note, however, that a person's size in general is not an indicator of how much love they received as a child. As we learned previously, around 80% of height is in the genes. Only 20% is influenced by environment and life. The point is merely that the genes are influenced by love and fear. And before you start worrying about laying your infant down for a short time, the scientists have discovered that if maternal touch was resumed, then ODC overexpressed by a factor of 300%, producing elevated amounts of growth hormones as if to make up for lost time. Nature, it seems, is not without a sense of balance. Infants also benefit from a range of experiences that don't always involve direct touch from a parent, for example, when they're playing with toys. So it seems as though nature has built this overcompensation into the process of evolution. Some researchers have actually discovered that a positive, loving environment in the home is ideal. While studying the brain, they learnt that the area known as the prefrontal lobes at the front of the head, just above the eyes, grows more pronounced if a child is brought up in a positive, loving environment. When a child is consistently deprived of love, there can be a stunting effect on its growth, and the prefrontal lobes don't develop fully. A well-developed centre of prefrontal lobes is associated with a person being able to express themselves comfortably, being emotionally well-adjusted, and being spiritually aware. A child with underdeveloped prefrontal lobes often has difficulty with emotional expression later in life. However, some of these effects can be reversed through love and care. In 2003 report in the journal Neuroscience showed that some of the negative effects on the brain of lack of love in early childhood could be reversed through good nurturing. Healing our wounds. Subheading. Many studies have shown that our thoughts and emotions even influence the healing of wounds. In 2003, scientists at the University of Auckland collected wound fluid from 36 patients following routine surgery. The patients had been given psychological tests before surgery to assess their mental and emotional state. The study found that the patients who were more stressed prior to the operation had less interleukin-1 in the fluid, which is a substance that is involved in the inflammatory response as a wound heals. This means that they had a weakened inflammatory response against infection. The patients who worried more about their forthcoming operation had lower levels of repair substances in the fluid, so the state of mind of the patients affected the rate of healing of their wounds. A 2005 study in the journal Gene Expression found that mental and emotional stress decreases growth hormone levels at wound sites, thus also showing that wounds take longer to heal when we feel stressed. In the study, the scientists found that over 100 genes were downregulated during stress, which means that in the light bulb analogy, the brightness of the bulb was turned down and over 50 were upregulated, which means the light bulb became brighter. And just as with the example in chapter 1, where hostility in marriage caused hardening of the arteries, hostility has also been shown to affect the rate of wound healing. Published in Archives of General Psychiatry in 2005, scientists at Ohio University found that blister wounds took longer to heal following a marital conflict. Wound healing requires the switching on and off of a number of genes. Genes must switch on, for instance, to produce the proteins that are involved in the healing process, as well as to produce the materials to make new skin cells. Any thoughts and emotions that lead to stress or worry have the effect of interfering with the normal on-off patterns of genes and thus slowing the rate of healing of wounds, just as they slow the rate of healing of psychological wounds. Most of us have had these experiences where we've been emotionally hurt in the past. Those wounds take longer to heal when we continue to allow negative or hostile thoughts to dominate our thinking. And so as the body and mind are connected, physical wounds take longer to heal too. So any way in which we can help ourselves to feel good will have a positive effect on the healing of our wounds, both psychological and physical. Genes and determination. So we are rarely stuck with a bad set of genes, so to speak. Excuse me. Learning and practice can offset any setbacks we might have experienced and can also enhance our natural abilities. And as we learn and practice, our thoughts and feelings switch on genes that help us to master whatever we are focusing upon. Similarly, our general state of health can be improved when we are determined to recover from an illness or when we are visualizing ourselves well. My mum enjoyed jumping when she was a child. She loved jumping so much that she became really good at the high jump as a teenager and performed excellently at the county sports championships. For years afterwards, she talked about jumping over the clothesline in her back garden every evening and the joy she felt from it. I was often moved by the excitement in her voice as she vividly accounted these experiences, acting out the jump emotions on the sitting room floor. As I grew up, I loved to watch athletics on TV with my family, particularly the Olympic Games. Inspired by my mum, I would often daydream about being an athlete and competing in a major championship. In my mid-20s, I tried out for the sprint team in a large UK athletic club called Sale Harriers Manchester. But although I was quite fast, I wasn't good enough to make the team. A few days later, I was at the track by myself playing around at jumping into the sandpit. After several jumps, the head of the club approached me. He had been watching me and wondered who I was because I was a new face at the track. He asked how far I could jump. So I paced out my last jump and said it looked to be about 6.5 meters, which is about 21.5 feet. He was visibly impressed and asked me to come to the track the following evening because that's when the long jump squad trained under the coaching of Terry Davidson. He wanted me to join the club as a long jumper, so I did, and I became very good at it. Within a month or two, under Terry's coaching, I was one of the top long jumpers in Scotland. But prior to Sale Harriers Manchester, I had never done a day's formal jump training in my life. Most of my training had been mental and emotional daydreaming. Then there is most likely a jumping gene or a set of genes that motivate a person to want to jump and thus develop stronger and more elastic muscles. I must have been born with favourable genetics, but then again, I may not. The right genes may have simply been turned on because of the thoughts, feelings and motivation I was exposed to through my mum's love of jumping. these mental and emotional experiences would have written a new genetic program, switching on specific genes that cause my muscles to develop and perform in an appropriate way. My ability would therefore have been independent of whether I had inherited athletic genes or not. When a person is highly motivated, genes switch on, brain cells grow, and proteins are manufactured so that the person begins to evolve into the image of themselves that they are striving to become. If you think about it, it is doubtful that every Olympic medalist will have been born with athletic genes, but I believe that numerous genes will have been encouraged to become switched on through the athlete's sheer determination and willpower. All of us have the capacity to become pretty much anything we desire because we all have the genes in the gene pool, and they're all susceptible to mental and emotional influences. The question is simply, what are you motivated to become? There are probably no limits to what any of us can be. All of us have the Olympic athlete gene waiting to be expressed, and the great artist, sculptor, musician, actor, scientist, writer, teacher, peacemaker, lover, parent, genius, and healer gene. It's all in your DNA, just waiting for you to want it and have the faith that you can be it. Many people's latent abilities are obstructed by their belief that they can't do something. Who says you can't? You can. Everyone can live their dreams, regardless of past conditions or the performance of family members. Anyone can have the desire and a little faith, and that might be all that is needed. Look to what's in your heart. Oh, that was good.